Okay, hello students. I hope you are well since I last saw you. It's been a couple of weeks since we saw each other during the lectures. It's as you realize, we're not going to see each other from now until the end of the semester. We can always be in communication through different tools, but the lectures and the evaluations will move to online, and we're doing this because of the situation with the COVID-19 pandemic and the whole premise of social distancing. So in this video, I wanted to explain to you how we will proceed in the TELE-28649 course, the Wireless Communication Systems course, and how we will how hopefully you will complete the expectation and the evaluations for this course, and hopefully you will do okay, and then move on with your other courses or your graduation. Okay, so let's go through the motions. Okay, so here what I wanted to go through is the lectures and evaluations that we have completed so far. I think it's important to know what we've done in the semester, in order to identify what's left and how we could proceed. So this slide will essentially show you that. So we went through 9 weeks together, and the first week we gave you the introduction to wireless communication systems, a big overview of the history, OSI model, system level communications. We talked about transceivers, modems, and so on. The second week we moved into transmission modes, different type of transmission modes, half duplex, simplex, and others that we discussed in class. BER, electromagnetic radiation, RF, spectrum management, wireless technologies, the different wireless technologies that we have, licensing, unlicensing, and some new advances in RF integration. So we saw all that in week 2. In week 3, we were lucky to have an IEEE ComSoc distinguished lecturer from Bell Canada. So he came, Javan Efrayan, he came, he presented to you an overview of 5G communications and 5G deployment in this country, in our country, in Canada. And we got an update of what's going on in the area of 5G around the world, but particularly in Canada. In week 4, we moved along and we started to talk about the different distortions that could have that a communication system will have. So we talked about attenuation, noise, interference, fading, shadowing, and we talked about some of the impacts that these different components have. We also distinguish the different deteriorations in the channel for a wired communication versus a wireless communication. And we saw that in which scenarios a wired communications make sense, and which scenario wireless communications make sense, and the pros and cons of both. I might do a short video of that later on, but we'll see. But in fact, we did cover this in class. We also discussed the type of ways the wave is detected at the receiver, whether it's line of sight, weak line of sight, or non-line of sight. We saw that through some examples as well. I also wanted to cover during this week, in week 4, AWGN, SNR, SINR capacity, and spectral efficiency. However, we did not have time to cover that. I remember we had a lively discussion in class, as we usually have in class, and during this week we could not go and cover the other factors here, the AWGN, SNR, SINR capacity, and spectral efficiency. Therefore, we have to cover this. It will be part of your final exam and your quiz too. It wasn't covered in the first part of the course. We need to push it out, push it to the second part of the course. In week 5, we had our quiz, the first quiz. It was 5%. It was, so we did that. You guys did it, and you got the grade. We also discussed, with the remaining time, the type of antennas that we have in wireless communications. We discussed electromagnetic propagation, antenna gain, antenna efficiencies, and the different ways by which we could quantify the gain of an antenna and the actual meaning of a gain of an antenna, the different type of antennas, and then the gain that they have, whether they're directional, omnidirectional, and we saw the variety of antennas in that lecture. In week 6, we went along, and then we specifically got introduced to the Friis formula. We introduced to you the concept of path loss, and then showed you the most basic model for path loss, which is the free space path loss model, and we told you how this is mostly valid for satellite communications, but also if you really have an idealistic line of sight communication, sometimes this could also be valid. We also did a bunch of problems and exercises related to the link budget, and many of the exercises and problems that we did were of practical significance. So we saw, for instance, how to derive the gain of an antenna based on the dimensions of an antenna. We saw how to determine the receive power from a transmitter. We also determined the path loss, quantify the path loss, and we saw the interplay between these different elements. So I think one way to really understand the significance of system level communications is really to understand the link budget. The link budget gives you a good sense of the basic fundamentals of wireless communications, system level wireless communications. So we did that here. We continued with problems the week after in week 7. Week 7, we had a holiday. Our lectures are usually on a Monday. We had a holiday, but nonetheless, we booked a makeup class on Thursday, and then we continued with the concept of link budget. So overall, I think we solved in class somewhere around 8 problems, 8 very comprehensive long problems, and as you know, I solved all these problems by hand, and I uploaded them on Slate. So you have it on Slate as well. And then you had our reading week from the 24th of February to the 28th, and then in week 8 you did your midterm, and I gave you the results, so you saw that. One thing that is missing in the midterm, and I know some of you wanted to see. Wanted me to solve the problems of the midterm. And I specifically wanted to do that not in week 9, because at that time I did not have I did not finish marking your papers, but I wanted to do that in week 10, and in week 10 was canceled. So unfortunately we weren't able to do that. It is very hard for me to go through the marking of the midterm on a video. I think it should remain private, so I cannot do that in a video format. But if you still are interested, or if you have some concern, I could always be reached by email regarding that. Then in week 9, we then began the second part, the second part of the course, and now we went into mobile communications. As we told you in class, mobile communications will have a significant importance in from 2020 onward, especially with 5G communications. And I wanted you to really appreciate the significance of what this technology is all about. So we talked about different technologies before that, particularly about Wi-Fi, Bluetooth, Zigbee. We discussed all these different technologies. Now we're moving into mobile communications. And slightly shifting toward that, with some also component of IoT, right? So some of the IoTs will still be valid within 5G, like narrowband IoT. It's still part of 5G, or LTE-M. That's still also part of 4.5G and 5G and so on. So we will discuss that within this part, but essentially it will focus on mobile communication. So we talked about the evolution evolution of mobile communication, how we went from 1G, 2G, 3G, 4G, and today in 2020 onward, we're talking about 5G, and in 10 years from now, around 2030, it will be 6G. And we showed the trend on how these Gs are come about. We also talked about standardization of the mobile communication and its relationship with the 3GPP standardization body. We also discussed the geometry, very quickly, the geometry or the different component of a cellular communication, in particular cellular networks, base stations or eNode Bs, the UEs, or the mobile stations, the MSC, the cell coverage, outage, and so on. So all that was done in week 9. At the same time, I need to highlight that you have the lab. So I guess you went through the first project here, second project, and then the third project on the next slide. Okay. Okay, so now that we've seen what we've done, and on this slide, I wanted to show you what we haven't done, or what is remaining in the course. So let's go through them gradually. Number one, well, we were supposed to have a lecture in week 10, but as you know, all classes were canceled at Sheridan, and so the lectures, the labs, they were gone because of the COVID-19 pandemic. So that was lost. And if you're keeping up to date with the news from Sheridan, this week that is lost is not going to be given to us, so it's lost, and there's nothing we could do about it. So we will, instead of having week 10, 11, 12, 13, and 14, now we 1 week is gone, and then we're left with 4. So we have to manage to finish the course with the other weeks. So this coming week, this week that I'm talking to you right now, week 11, we will continue the discussion that we had on mobile communications. I introduced very briefly or very quickly the concept of geometry and the meaning of geometry in mobile communications. And in this week, we will go in depth into what it means, the significance of it, why it's so important. I mean, of course, we said that in system level communications, power is everything, right? Power decides the level of your communication. How much do you, what is your received power? And in reality, it's not just the power, it's really the SNR or the SINR that tells the quality of your signal. So it's not always the power, but it's how it's compared to the junk in the channel. I mean, I'm loosely saying the word junk, but essentially the noise and the interference in the channel and the distortion. So how it compares to it, that gives you the significance of your received power. And at the end of the day, it's power. And power is a function of where it is in space, right? So the geometry becomes very important. So we'll talk about that. We will also discuss frequency reuse, the concept of frequency reuse in cellular communication, what it means, how it's used, and give you a quick overview of this. We'll discuss cell sectoring. I showed you when we did the antennas, we saw the concept of directional antennas. You know, you have different antennas, they have different beams. You either have a very wide beam, and if you have a wide beam, your energy is sent you know, in all directions. Whereas if you have a directional beam, you compress all your energy that you have into one direction. So we saw that it has some advantages. One of the key advantages is that you will get more power, right? Your power level that you will get to somebody that is requesting, that is waiting to receive a signal will be higher as opposed to when you have an omnidirectional antenna. And in addition to that, interference will be minimized because your energy is not wasted and gone to other people. And if that's the case, then you'll end up getting interference. So interference is minimized, and the data rate is increased by having a directional antenna. So we saw that, and we compared it to an isotropic antenna. This idealistic theoretical antenna to figure out how this is done. We'll go more in here in cell sectoring and understand what it means in a cellular perspective. We'll explain to you the concept of downlink and uplink between a UE, a mobile device, and a cell tower. And we will talk then on interference. So there's a different type of interference when we talk about cellular communication. You have intercellular interference, you have intracellular interference, and you have co-channel interference. So these are different type of interference. There's also another one. There's adjacent channel interference. So ACI. We're not gonna. So it's also discussed here. I'll explain it. So within the concept of interference. So we'll go through that as well. And so that should cover our week 11. Now, in addition to all this, we also need to discuss the topics that I showed you on the previous slide, right? That were supposed to be discussed in week 4, but because we didn't have time, so we now have to push it to this week here. So I want to kind of give you an overview of AWGN, SNR, SINR, capacity, and spectral efficiency. We talked about it, but now I want to specifically show you the equations and the mathematics behind these different concepts, right? So we understood what it means conceptually, but how do you quantify these things theoretically? How do you model it, and how do you quantify it in order to analyze a system or to design a communication system? So we'll go through that as well. Now, I do recognize that our lectures are essentially 2 hours, and then if we remove the breaks, that's an hour and 40 minutes. So we have a lot in week 11. So I don't know. We have to relax some parts. We'll see how we're going to do that. Perhaps the interference part will go a bit quicker, but we'll see how we're going to do that. Okay, so it's going to be one video on the geometry and interference and frequency reuse, and a separate video on AWGN, SNR, SINR, and spectral efficiency and capacity. In next week, so the week after next week, you will have your quiz. Your quiz will be on Thursday, right? So I know that you guys prefer to have your evaluations on Thursday as opposed to our typical allocated Monday slot, and that's okay with me. I do not mind. So it's going to be in the morning. I'll give you the details in a second. So you'll have that then, and then we also have some part that we want to discuss in that week as well, which is radio propagation. How does propagation operate under a cellular communication connectivity or link? I'll also explain to you the process for estimating the path loss exponent in mobile communications. This is a practical concept that you need to understand how it's performed, and then we'll get a sense of what it means what does path loss exponent mean, and how it is different in different environments, and how you can actually measure it, right? How do you actually measure it? What do actual telecommunication engineers do to measure that? And we will also do some problems, and you know, with problems I always like to show you how the problems are solved. So we'll solve some problems so that you get a sense of the process for problem solving techniques. So you learn that. Then in week 13, suddenly we leave Earth and we go into outer space, right? So we look into the sky, not only to the sky, but in deep space. So we're looking on satellites at different altitudes, different high altitude, and you know, they're all at LEO, MEO, GEO, or HEO, and I'll explain you what this means later on. We'll also explain to you some of the satellites that are geostationary, because I think many people, at least if they know anything of satellites, they have a sense of what geostationary is. We'll go through that in particular. And I will explain to you the relationship between a spot beam of a satellite and your coverage, right? So what does it mean to have a big coverage from a satellite or a small coverage, and how does it vary with frequency, and how does it vary with the communication data rate, right? How speed is your communication? And so satellites are, have a major problem with in regards to latency, but then can you modify that when you go into high frequency as it's happening right now? So we'll see the relationship there. We'll talk about the coverage map. I also will introduce you to some of the basics of CubeSats. So CubeSats are interesting. There's this is very interesting for university students and college students, where they build their own CubeSat and they send it to space. So this is interesting to kind of be introduced to the concept of this. There's also a new concept these days that everybody in our research area are discussing as of recently, which is the concept of satellite 5G integration. So for 5G, and in fact 5.5G and 6G, we will probably be looking at elevated support. So no longer support from the ground, but really support from either drones or anything beyond that. So people are considering the benefit of using satellite and to integrate satellite communication with base stations on the ground in order to help with the high densification of network. So we'll talk about that, and we'll see some of the paradigms in this area. We will also introduce you to GNSS and the use of satellite in positioning to figure out where you are in space. Basically GPS, right? Your GPS positioning. GPS is a US technology. Also, since we're talking about that, it's the most famous one. Everybody knows GPS. But I also wanted to introduce you to the Galileo constellation as well, so you'll be familiar with that. We won't have much time. Satellite communication is a big field. If you were to take courses on this, you might be spending maybe I don't know, 3 or 4 courses just on satellite communication. It's a huge field. There's a lot of materials to be learned here, but we won't have time to do that. So we're condensing this very quickly to just very basic stuff. So at least you're familiar. You get introduced to the concept of satellites. But certainly satellites will play a major role in our near future. As you can see with the satellite 5G integration, this will be very critical, and there's a lot of news on this front. Now, once this is done, then what would be left would be your final exam. Here, I guess I made a mistake here. I wrote midterm exam, but this is wrong. It should be your final exam. And your final exam will be worth 30%, similar to the midterm. And so again, this is wrong. It's final. It's worth 30%. It will be 90 minutes, and it's going to be closed book. Okay, and that's it. That should cover the course. So we got a lot of challenges with this. Shifting a classroom teaching to online teaching, but we will try to navigate along, and hopefully you will you'll get the essence of the course, and you'll be able to finish effectively and hopefully learn as we go along. For me personally, face-to-face interaction is the best way to learn. That's my view on it. But let's hope online learning is also feasible. But we'll see. Now, for your evaluations, your quiz 2, it will be, you'll have a window to do this between 9 a.m. and 9:20 a.m. on Thursday, April 2nd, right? So you need to mark this. I already, dedicated the time on Slate, so you should be notified through Slate. And the topics that will show up on your quiz 2 will be AWGN, SNR, SINR, channel capacity, spectral efficiency. These are the topics, right? And in addition to that, the content of week 9, so basically cellular communication, and the content of week 11. So that should cover your quiz 2. For your final exam, It will be on Thursday, April 16th from 8:30 a.m. To 10 a.m. And in here, it's the same stuff that we have from your quiz, and now we only add the new content of week 12 and week 13. So we add these two in addition to what you saw for your quiz 2. These two are added, and that should cover your final exam. The final exam will require some problems that are, well, I mean, the final exam and the quiz will be, some of them will be conceptual questions, and some of them will be numerical questions, right? The questions where you actually have to solve and then figure out the answer. Okay, so that's the format that we will proceed. So please mark your calendar, and please make sure that you have connectivity to do your exam. Now, in this slide, I wanted to give you an overview of how we will deliver the content for this course. As you guessed it, since you're watching this video, the course material will be delivered to through slides, but also through videos. Essentially, for the lectures of week 11, 12, and 13, I'll give you the slides. So you'll have the slides. It will be uploaded to Slate. Just give me some days to work for the slides for this week, and then for the others, every week you'll get the slides that are required. So you will essentially have the content before your quiz 2, and then the content related to that before your final exam. So you'll have that. In addition to this, the materials for the AWGNS and ISINR capacity and special efficiency is already available in lecture 4. It was there, it's already on Slate, but I recall telling you that for your midterm this is not covered, so I assume people did not read it, but it's there, so you could always go back there to read these topics. Now, what I will do is, for all of these topics, some of the material from lecture 4 and the content of week 11, 12, and 13, I will do a voiceover, essentially videos, and I will upload these videos to Vimeo and YouTube. So you'll have the option to go to one or the other to see them, and I will update you on Slate. So you'll know when the videos are ready on Slate, so you could go and go through the lectures. As you can observe, we will not use virtual classrooms, but rather give you recorded lectures. Now, I know that because of this disruption in the educational system, Sheridan and in different places around the world, some people are considering virtual classrooms, and we have that. We have that at Sheridan. Some of my colleagues are using virtual classrooms, but I'm not using it for this course, and there's really 3 reasons for this. Reason number 1 is that it avoids overloading the virtual classroom capability on Slate, so we want to make sure that it doesn't overload it. When you have multiple instructors and professors using it at once, this could happen. So we will try to avoid doing that. And in addition to that, we want to give you the flexibility. So it provides you the capability to go through the lecture at flexible days and times. We don't know how the situation is with different people, whether they're involved in work, like in shopping centers or supermarkets or whatever the situation might be, or they're sick. So we don't know the situation of different students. So we wanted to give you the flexibility of day and time, so when you could watch it. Okay, and in addition to that, it's good because you could move on at your own pace, right? So if it's a video, you could pause, you could go back, you could rewind, and it's better in that way as opposed to having a virtual classroom where it's actually live. The inconvenience of having recorded lectures, not a virtual classroom, is that the interaction is not there, but I am always available through email. So you could always send me your questions or concerns through email, and I will try to reply to you as soon as possible. In general, I take 1 business day to get to you, sometimes faster than that, but always available. If you do send me an email, please do not send me an email on my private email or my email on my website, but rather use the email from Slate, right? So if you send me an email, please use Slate to do that. Okay. Finally, on this slide, I wanted to quickly give you the guidelines for quiz 2 and the final exam. So as you know, we are going through the process of social distancing, and so we're not going to do the exam in a classroom or in a physical room. We will do this remotely using your computer, right? Your computer, and connected to the internet, and you will log into Slate, and then you'll do that on Slate. So I'll just explain how we will proceed with this, and then you'll know the guidelines here. So number one, the evaluations will be administered on Slate, as I mentioned right now. You will need internet and a computer access for the evaluation. This is very common sense. Now, some might be tempted to use, any electronic device, let's say a cell phone or a tablet. This is not recommended. It is ideal for you to do the evaluation using an actual computer, so your laptop or a desktop, that if you have a desktop, but not a cell phone or a tablet. So in other words, no handheld devices, but rather a computer. You will have 5 minutes. You will have a 5-minute window to start the evaluation, right? So as I told you earlier, the evaluations have specific windows where you could they begin. So you'll have 5 minutes to start the evaluation. So just make sure that you're there before the time begins, and so that you could monitor and then log in and begin the exam as soon as it begins. If you don't do that within 5 minutes, the system will lock you out and you cannot proceed with the evaluation. So this is very important to remember. You are working remotely. You're doing this from your home or whichever place you are. But at the end of the day, this is a closed book evaluation. I mean, you won't even have time to look at anything, right? There's a clock that is running. There's a bunch of questions, so you want to solve as soon as possible and then move on. So the exams are designed in such a way that it is designed for a closed book evaluation. These are kind of common sense things, but I'll mention it anyway. So you're not permitted to communicate with others during the evaluation. So just keep that in mind. You will need a calculator and a blank papers for rough work. The questions will most likely be multiple choice questions. I still didn't design these evaluations, but that's how I'm thinking of doing them. But you will need a calculator. So make sure you have your calculator with you, and you will need to do some calculations. So also make sure that you have a place where you could do some rough work or some to play around with some equations. The time remaining will be displayed at the top of the screen. So you'll have that at the top of the screen, and then it shows you how much time you have left. So make sure you finish and submit the evaluation before you run out of time. So if you take too much time for some questions, then you won't have enough time. So you have to kind of work in a smart way. You have a certain budget of time, and you have to use it effectively. So you have to do that. Now, also another thing that I'd like to mention to you, there will be multiple questions, right? So no two people will have the same questions, and they will be randomized. So the numbers will be different, and also the sequence of the letters will be different. So all this is done in order to minimize the likelihood of plagiarism or cheating. So I hope you're all aware of this, and I wish you the best of luck as we finish this semester. Okay, thank you.